Hello everyone. So in this lecture, I'm going to explain you about blockchain, Ethereum, and smart contracts in a very brief, so that we can understand the upcoming parts very easily. So let's jump into the first part, which is blockchain. So you might have heard about blockchain many times in the past few months or the years. So what is it exactly? So a blockchain is nothing but a decentralized data structure which stores information in the particular format, right? So I'm going to actually explain you in a very simple language rather than explaining you in a very complex manner, which maybe you'll forget very easily. So I'm going to use a very simple language. So data structure. So if you are not aware of the data structure, it's nothing but an arrangement of data. So remember, it's just an arrangement of data in the computer memory. It's called a data structure. So blockchain is nothing but a data structure which is a special kind, which is like this, which is called a type of blocks which are connected to each other. That's why we call a block, and the chain, it's called a blockchain, right? It's a data structure which exists on a peer-to-peer network, or on a decentralized or a distributed network, right? So means this data structure will not be residing in the single server or a place or a computer, which generally happen in the case of Excel sheet or a MySQL table, which reside in the particular server or a computer. But this blockchain will be actually existing on the multiple computers at the same time, and the recording and the deletion, or whatever you can call it, right, all the operations on this data structure will happen through a peer-to-peer network rather than on a centralized server where you send the query and then you get the response. This is not going to happen in this. Okay, so let's talk about more about the blockchain. So let's relate it with the real life analogy so that you can understand the blockchain better, right? So imagine it as a book where the each page references to the previous page through a page number. You know that every book has a page number, and if you tear down one particular page, it is very easy to detect because the page numbers are actually connecting the each page. So if you change the page, then it is easy for someone to identify if that page has been removed, or somebody has tampered the page, sorry, they tear down the page. So it is easy to arrange the pages and identify any suspicious activity about the deletion of the page. Remember, not the alteration of the page number, of the page content. So that's why the page numbers are very important in the agreements, because the total number of pages should be written everywhere in the each page, so that everybody know, okay, there is, if there is a page missing, it means something wrong. Okay, but the question is, what if the content of the page has been altered, right? So how will you ensure and check every time that a particular letter on page number, let's say 26, has been altered by someone? So in that case, you can have to, to solve this or to answer this question, what you have to do is you have to just produce the page number by crunching the content of the page, or you can say crunching of the previous page. So if you create a page number in a particular, let's say in this, right, if this is a third number slide, if this third is being actually created by using the entire content of the previous page, right? When I say entire content of the previous page, that means the entire content, which includes the page number of the previous page as well. So this, as well as the whole this, will be crunched or converted into a small string, and then that small string will be called the next page number, right? If this happens, then you can understand, if I do this, when I say crunch, it means the digest or the signature of the entire page. Digest algorithms actually converts the any size of string into a fixed length of unique strings. So if that happens, then even if you change, let's say this, if you delete this letter particular called a, then the page number in the new, or you can say the page number of the new page will not match, right? Because it's there already from which is coming from the previous page digest, which means that it will not match, and the entire block or entire book will actually be invalid from the page from where you altered the data. So if you have altered the data like this a, then the any page which follows this page will be invalidated and will be disconnected from this book, right? So that's how the blockchain works, right? Each block is actually built on top of the previous block, right, in such a way that the signature of the previous block has been kept in the new block, right? So if you alter anything, anybody can actually easily identify. So that's how the blockchain works. The each blocks are connected to each other in such a way that the signatures are connecting the each block, and the whole blockchain is actually available entirely among everyone in the network. So there are tons of computers connected to each other, right? forming a peer-to-peer network, and each one has the entire copy of the book. Let's call it a book if we're talking about the real life analogy. Okay, so in real life, the blockchain case, the each block is built on top of the recent block and use its previous block's content as a signature, right? Then building a block and adding it into the blockchain is the task of the miner. So right, so when we talk about the multiple computers connected to each other, then some of them are called miners who are responsible for adding the data into the blockchain by actually compiling the transactions into a block and putting the entire block into the blockchain, right? So it's like this, right? Whenever the new lines of the text in the book comes into the whole network, one miners will actually collect all the lines together and put them into a page and then add that page into the book. So that's called a mining process, right? So in public blockchain, it is made computationally difficult to add a block to prevent the attacks, because if somebody has done something malicious on a previous pages, he would like to replicate the entire upcoming pages so that he can avoid the suspicious activities. But or sorry, he can avoid the identification of suspicious activities. So it's intentionally made difficult to create a new block, right? So miners try to guess a number in such a way that if it gets crunched with the most recent block's fingerprint, then it will create a new fingerprint which will be less than that the most recent block. So every page number, let's call it a page number, right? So every page number must be lesser than the previous page number, so that the block has been created in such a way. Remember, the page number is being created not by just crunching the entire content of the page, let's say entire content. So this page number will not be generated just by the previous page entire content. There will be an extra random number that will create it and will be kept at the bottom. So that number need to be guessed by the miners. That's called a mining, right? That becomes a mining process. So since it is actually computationally expensive and there is a difficulty of involved, then so the miners actually receive a reward, because nobody do it for free, right? Why should I invest my computational or power or the computer to the blockchain, right? So I need something in exchange of that. So currently the Bitcoin case, it is 25 BTCs or 25 Bitcoins, which is around 13 to $14,000 right now every block. So that's why, and that 13 to $14,000 are very huge cost. So it means that Bitcoin challenge, the adding a blockchain must be block into the blockchain must be very expensive and difficult. So private blockchains can use any other method to add the block, as they can trust the miners using the contract, etc. So this is how the small, the block look like. As I already told you, that previous block signature generally kept on the top of it, and then there is a random number which is generally added at the bottom of it, which then create the whole signature. Okay, so I already told you that's a decentralized distributed ledger, or the data structure where the data is being stored inside the blocks in form of transactions. It removes the dependency on the trusted third party for recording the data in the blocks. In public blockchain, more complex algorithms required to avoid the malicious activities. I've already discussed and explained you that, right? Since the each block is built on top of the previous block, immutability has been achieved. Because if you change anything in the previous block, the entire blockchain will be, or the upcoming blocks will be invalidated, and it is easy to detect. That's how the immutability has been achieved, right? Data itself is not immutable at all, but if you do change something, the whole system will fail at his own level. Then it is easy to identify the changes. That's why it's called immutable. It is very difficult to fake a block and very easy to detect a fake block. That's called a immutability in different language, right? So this all exists in the memory of computers, and there are software programs which are running and connecting and talking to other computer softwares. So that's simply a blockchain. So every participant of the blockchain contains the almost the same copy of the blockchain. That's true. Almost same, not exactly the same. So what is Ethereum? So Ethereum is another open source blockchain, and which is actually also the first version, or you can say the different version is Bitcoin. So Bitcoin is also a open source blockchain, but Ethereum is a different kind of blockchain which actually offers a feature called smart contracts. So it's a distributed computing application platform which allows you to create your own smart contracts and let it execute on the entire blockchain through peer-to-peer network, right? So it offers a decentralized virtual machine, also known as Ethereum virtual machine, and of course Ethereum is having own the virtual currency known as Ether, right? So just like in Bitcoin has a Bitcoin, the Ethereum has Ether as a virtual currency. So Ethereum live blockchain was launched in 30th July 2015, and this is the logo of the Ethereum blockchain. Ethereum. Next question is, what is smart contract? So smart contract is a term used to describe the computer program code that is capable of facilitating, executing and enforcing the negotiation or performance of an agreement, right, using blockchain technology. So it's an application of one of the blockchain technology that we are talking about. The entire process is automated and can, act as a complement or substitute or the legal contract, right, where the terms and the smart contracts are recorded in the computer language as a set of instruction. So rather than signing a paper based contract, you can use this programming based contract and enforce and execute the penalties, rewards, everything using some triggers. That's called a smart contract. Okay, so that's all for the brief explanation about the blockchain, Ethereum and the smart contract. So we'll continue the what exactly the the uh, other the Azure platform offers blockchain as a service, and we'll talk about it. Thank you.